All right, now, so chemistry basics, matter and measurement. This is the first chapter. Realistically speaking, according to the international standards and according to the United States standards, about half of this chapter or more should have actually been middle school science, in case you're wondering. This and the next chapter are actually review for the most part. You may encounter a few things here and there that are new, just because I'll expand on them more than you would have been in middle school or high school. Because I don't think any of you probably had a PhD teaching chemistry in middle school or high school. But if you did, you actually had a really good one. That's really impressive. Okay. So every time what you'll see is I'll have the chapter. I'll have these outlined pretty closely to your book, as closely as I can have them. And this is a sort of outline. By the way, this would be what you would traditionally be given in a review packet, right? The outline of the material covered. I don't give you review packets because I actually give you everything before. I just don't give it to you all in one deal. And that's because I'm going to equally test over everything I cover and everything I asked you to read and all the homework assignments I did as equally as I can do. Okay? So, matter is going to be anything that takes up space and weighs something. Pretty simple definition. Everybody probably already knows most of this stuff, but we're going to think about it in much more concrete view. So there's two types of matters. There's pure substance and there's mixtures. In your head, I want you to develop a flowchart here. Okay? And I'll actually give you a flowchart at the end once you have these definitions. So pure substances will be classified as elements or compounds. Mixtures are going to be classified as homogeneous or heterogeneous. Now, if you're on the other side of the Atlantic in some other countries, this is homogeneous and heterogeneous. Okay? And you'll sometimes hear me flip back and forth because, for reasons. All right. Now, a pure substance is going to be a matter that is made up of only one type of substance. It can be represented with one chemical formula or symbol. Okay? This would be very rare for you to encounter in actual life, right? Mostly these are going to be theoretical things and things that we sort of count as pure substances but aren't really. Okay? Element. This is going to be the simplest form of matter because it's made up of only one type of atom. An atom is going to be the smallest unit of matter that keeps its unique characteristics. Now, that's a very good definition. So essentially, if you were to cut something up over and over and over, it's going to get down to a point where any more cutting up of it is going to actually change what it is. So it'll no longer be gold. It would no longer be hydrogen. It would no longer be silver. Okay? And that would, in fact, change the chemical properties, what chemical it is, what compound it is, or in this case, what element it is. Okay? Now, we will talk about nuclear chemistry, which is what that is. But we'll only cover it in very small amount of detail in this course, okay? Because we just don't have time to go over every chemistry. That's why there's a whole PhD program in that, right? Now, a compound. This can be a pure substance that's made of two or more elements that are chemically joined together. You know compounds because they're things like water. Okay, water is a compound. Or CO2, carbon dioxide, that's also a compound. Now, mixtures. These are going to be a combination of two or more substances. So if you take two or more of these things, mix them together, that's going to be a mixture. Okay. Mixtures are almost all of the things you encounter in your life have been mixtures. You've basically never seen a pure substance. You've seen a few pretty pure substances, and that's about it. Okay? Probably the one, if you were going to see a pure substance, it would have been a pure silver. Most likely.
Lead or graphite?
They're pretty pure, but they have quite a bit of impurities.
Okay.
Yeah.
Gold. then? So if we've
gold,
got really good
you've
gold
actually,
or a diamond.
Yeah, you might have seen diamond would be the other one. If you've seen a lab-grown diamond,
Okay.
you've probably seen parts that are pure substances.
Okay.
Actually, diamonds would get pretty pure.
Okay.
Yeah. Gold is never. You've probably never seen pure gold
Right.
because like karat gold,
14
24 karat,
karat gold.
Exactly.
What's the purity carat wise when you have to get?
I actually
gold?
don't remember what the carat scale is. I think that's only like 50%.
Okay.
Yeah. I'd have to look it up though. I think 24 karat is 100%.
Okay.
And then goes down from there, if I remember correctly.
Okay.
But I just not my thing. But yeah, those are mostly other metals mixed in. Okay. The other one that you see quite a bit pure is you see quite a bit pure silver. Okay. But not on like jewelry and things. It's actually on like electronics. Yeah. Yeah. Okay. Yeah. Okay. So that one actually would be another one. Mm-hmm. They're pretty pure, but again, they're still only like 99.999% pure. Okay. They're still actually mixtures. Yeah. It's very difficult to purify something that much. Homogeneous mixture. So this is going to be one whose composition is actually the same throughout. And so if you look at a mixture and you can't tell the difference from one spot to another, this is homogeneous. Okay. This is most of the drinks that you've seen are probably homogeneous mixtures, right? Like, for example, the water I'm drinking right now is a homogeneous mixture. It has salts in it. That's actually what gives it its like flavor. Has anybody ever had distilled water and drank that? It tastes weird, doesn't it? Yeah. Yeah. It has like this weird kind of mouthfeel. Mm-hmm. And it's a little oily tasting kind of. Mm-hmm. Yeah. Heterogeneous mixtures. These are going to be ones whose composition is not uniform throughout, but actually varies throughout. So you all are seeing heterogeneous mixtures. If you're looking at me, if you're looking at the screen, these are all heterogeneous mixtures, aren't they? Like my face, I have pores in it. I have different parts of my face, right? And so that's a heterogeneous mixture. Okay. Badly brewed tea or coffee can also be a heterogeneous mixture. Well brewed tea or coffee is a homogeneous mixture, right? Yeah. This right here is the flow chart I'm hoping you have in your head now and sort of how you want it broken down. Can everybody see it okay? That kind of what they have in their head now? Right. And that'll really help you break down these classifications of matter and understand science better. Okay. So the periodic table of the elements is actually a listing of all the elements that are, we have discovered, not just on Earth. The periodic table actually consists of many small blocks. Each block holds a different element. Each has a letter or two at its center and numbers above and below these letters. You can see a periodic table of the elements up there, but I've also passed them out and handed them out. So in case you can't see that as well. What you'll notice is that there's sort of three main items that are on all periodic tables. And then from there, other things get added here and there. Okay. Periodic tables are not the same everywhere. They can be a little different here and there. Okay. It kind of depends on when they were published and what people cared about when they published them. Mm-hmm. I'm never going to make you memorize periodic table. You'll have a periodic table on every exam. But you should kind of get used to them. There isn't really okay, so you're talking about the bold up here? Okay, so what those are actually is the ones that are not bolded are actually man-made. Okay, the ones that are bolded are made in nature. Okay, and if you ever look on a periodic table and you see three letters, that's because they haven't come up with a name on it yet. Yeah. It's a temporary name. They are still usually fighting. So the people that name the periodic table are kind of infamous because they get into like these fights, and they once got into a fight and broke up for 10 years. Didn't name anything new. That's why you see these kind of like 5-year-old-ish periodic tables, 10-year-old periodic tables that have a bunch of 3-letter designations on the bottom because they didn't name anything. because they were in a fight and wouldn't meet. As far as I remember, the only reason it stopped and they actually started naming things again is one of the members died. So, scientists. What are you going to say? So the letters are going to be the chemical symbol that's going to represent the name of each element. Though keep in mind, because of the naming, it's only 2 letters. They had to get creative sometimes, right? Like sometimes they already had what they should have used, and they had to figure out something else. Okay. And so for most of the elements, the symbol is going to be derived from the name of the element in some way. Okay. Sometimes it's how it sounds. And so it's the parts of it that sound out. Okay. Sometimes it's going to be literally just the first letter or first 2 letters. Okay. They try their best there. But some are going to be symbols that are derived from the Latin. For example, Na for sodium is actually the Latin for that name, which is natrium. Okay. Interestingly enough, these were actually much more common in the old periodic table, the ones that were discovered way back in the day, because Latin was actually the universal sort of language of science. English as the universal language of science is much more recent. In fact, German was the language of science up until about World War II. I'll let you imagine why. That was no longer the language of science. And then English sort of took over from there, but before that was French, etc. English being the language of science is very recent. Gold is Au. That's actually for aurum, which is Latin for gold. Some of these are actually deities, like pagan deities. Other ones are things like words for German for those. It's kind of like what language was popular at that time. Okay. But Latin is pretty consistently in Greek. This, of course, is the periodic table. You can almost not see anything here. You might be able to see it better over there. But you can already tell there's some differences between these, can't you? Weird, right? So what you'll see here is that you have periods down here, 1 through 7, and then there's groups going across. Okay. And then there's sort of 2 group numbers. There's 1, 2, 3, 4, 5, 6, 7, 8. And those are followed by A's. Those are called main group. Okay. And it's because if you look up to this point right here, that's about 90% of the mass of the solar system right there. Okay. And so the vast majority of chemistry, the vast majority of stuff that's going on in the solar system, right there. First 2 periods, you're good. The first period alone is already like 70% of the solar system, with hydrogen here being the majority of the solar system because of the sun. Yeah. Sun weighs a lot. Down here, that's the rest, with some interesting spots where you get like big leaps and some places where you get big falls. And there's reasons for that, but we won't be able to cover them in this class, just too much. But what you'll notice is there's a second system of numberings. Those are the B system. And so, for example, 3B, 4B, 5B. Everybody see okay? And so that's when you're down here on the periodic table, and it helps you determine that. Okay? What you'll notice is there's actually a third numbering system, which you might all find on periodic tables, in which case all of these get grouped up into one group here. Everybody see there's like another numbering system, 8B right there? Yeah. Altogether, there's actually 5 numbering systems that drop off very quickly in terms of popularity. Okay? The 1A, 2A system, and then the 1 through 18 system are by far and away the most popular. All the other ones are kind of fringe things that are used for certain systems where you're trying to do certain types of chemistry. Okay? And they're very specific to be like shortcuts. Just a quicker way of doing stuff. Okay? You don't need to know most of those. You'll notice that the periodic table is split between metals, and over here is non-metals. See those yellow ones? With the exception of hydrogen, which is over here. That is something that's debated and argued about all the time, but for reasons, it ends up over here. It's because of how it acts chemically. This stuff right here, see how there's these green ones that for the most part have two sides that contact this zigzag line right here? Okay. Those are metalloids. They're like a mixture of the two. So they have some metallic properties, some non-metallic properties. Okay. With the exception of aluminum, which is considered a metal. Now, realistically speaking, depending on the date your book is published, is actually going to change whether these things are considered metals or non-metals or metalloids. Okay? These things actually get argued about and flip-flop every now and then, and they're very contested, right? It really depends on, like, somebody comes up with a new test, and all of a sudden boron becomes a non-metal. Okay? It's just, know that if it has two sides on that zigzag line, it has some non-metal properties, some metal properties. They're a little bit like each, okay? Aluminum is more metal-like. Boron is more non-metal-like-ish. But they're all a little weird, okay? Okay. Did you notice that as you go down on the periodic table, more things are metal-like? Okay, very good. Cool. Yeah, there's some nice trends in this. Okay. Who does this numbering, naming, all that is the International Union of Pure and Applied Chemistry, IUPAC. They're actually the ones that do the organic naming terminology as well. My advisor actually used to cuss them out all the time because he was an opposing system that they were coming up with. And he did not like how they did some of the things, which I fully agree. Sometimes they do some really weird stuff. But on the other hand, finally, we have a language that we can actually talk about chemistry all over the world. They were actually put into place because you could go across the street and have completely different names for the same compounds before them. So horizontal rows, again, periods. We have the metalloids. Now, there are several elements that are essential for human health. The ones that we need in the largest quantities is carbon, hydrogen, oxygen, and nitrogen. These are going to be the vast majority of biological molecules. They're what make up your sugars, your fats, etc. Okay. Macronutrients. These are going to be needed in quantities greater than 100 milligrams per day. They're going to include sodium, magnesium, potassium, calcium, and chlorine. These are the ones you actually need daily and fairly large quantities. But 100 micrograms is, not micrograms, milligrams per day is not a lot, honestly speaking. Okay. Micronutrients are going to be in quantities that are less than 100 milligrams per day. They're going to include iodine, fluorine, iron, zinc, and there's a few other elements that you'll see on the next table. These are things you need so little of that you can almost accidentally get them. Okay? If you eat like once every month and enough, you're going to get very likely enough. Okay? They're just things that you can actually kind of accidentally run into and be okay. By the way, anybody ever heard of iodized salt? Mm-hmm. Guess what that has? Iodine. Because they feared people wouldn't get enough iodine. Who here thought you needed fluorine in your diet? How about copper? Yummy. I need some copper. Gonna get my copper fix today. No. So these are the rest of the elements. You'll notice you need things like manganese in there. Some of these elements are actually toxic if given in the wrong oxidation state. And so it's kind of an interesting conundrum where, anyways, you need things like iodine and selenium and some very strange elements, right? Okay. Chemical formulas. What's my time look like? One more minute. I think I might be able to get through. Okay, so pure substances, again, are going to contain two or more chemically combined elements into a compound. These compounds are going to combine elements in specific ratios. These are referred to as chemical formulas. For example, we have water here, which is the chemical formula for water. That has two hydrogens bonded to one oxygen. Okay. If I'm in the other room and I say, hey, does anybody want a drink of H2O2? What do you say back to me? No. Why do you say no to me? I am. That's hydrogen peroxide, isn't it? Dang. No killing my students. And so if you were to go through and let's say you want two H2Os, if you put H4O2, is that the same thing? No, it's a completely different substance, right? Yeah, completely different. So you use coefficients if you want multiples of something, right? 2 H2Os. Okay, very different thing, right? It'd be like me saying that a human has 2 arms, 2 legs, and then I can do 4 arms, 4 legs, and that's 2 humans, right? No, that person's gonna have problems. All right. Anybody has any questions? You all have a wonderful day. See you next time.
Thank you.
Definitely.
I asked my daughter Lily, and she said she doesn't have you this semester.
She doesn't.
She said it'll be next semester.
It is, yeah. So most of them take the chemistry in their senior year.
Do they?
Yeah.
I just thought that was so funny.
Yeah.
I was like, we can be study buddies.
Not this week. Yeah. Next week. Okay.
So, for my book,
Yeah, you're gonna have to warn her.
I will. Will you do your plexi thingy with her clicker?
Yes. Oh yeah.
this is what it's saying.
Oh.
And it won't let me.
Mine's
get past it. Yeah.
Yours too?
We finally got
All of you?
the notes, the lecture, but it won't do this.
Oh, you're in Safari. Try Chrome.
I don't have Chrome. We have MacBooks.
You can get Chrome.
You can like download it.
Can
Or
we?
even
Yep.
Internet Explorer will work.
Okay.
I'd probably recommend you Chrome.
Okay.
Internet Explorer is sometimes very weird on Macs.
Oh, is it?
Yeah.
Oh.
And sometimes it's very weird with websites in general.
Got it.
But yeah, go ahead and get Chrome on
Okay.
and try through Chrome and let me know, okay?
Okay. Cool. Thank
If
you.
it's still not working, call up the bookstore.
Okay.
That's what
thank
I'll have to do.
Do you know if you have spots for Chem Lab for Tuesday?
Right now, it should be full. I haven't checked in the last couple days, but the last time I checked, it was full. And, yeah. Email me though, and I'll check again. Okay.
Thank you.
Liquor question for the when I was like the Canvas answer.
Mhm.
Our names didn't get
Yeah,
stated.
we held it up, but you
Yeah, you didn't see us.
Oh.
We
Okay.
held it up like this. It was never scared.
Okay. So if that ever happens again, just go, hey, Dr. Clausen. Okay. Do you have your clickers?
It's in my bag. Do we need to get it out?
Yeah. Let's go ahead and have other people go, and you can get your clickers up, and then I'll scan you for those. Okay.
We need to do the pre-lecture for chapter 1.
Yes, indeed.
Did chapter 1.
Yes,
so
indeed.
Get that done as soon as possible.
Exactly. Perfect. Definitely.
For one more question, I misunderstood the questions. I did the wrong. Is that
Okay. You can get your clicker out, and I'll redo them.
okay?
Yeah. Which question was it?
I just know it was one for the Canvas, through Canvas.
Oh, this one did actually. Okay, let me. This one actually was just a survey, so it didn't take points.
Oh, okay. And then the third one.
It's in here.
Did you need to do that canvas one?
Yes.
It'll be here.
This is
They were all right.
Oh, is it?
Yeah. A little too close. Okay.
my first
Thank you. It's okay.
And did you need to do any others?
No, that was it.
No. Okay.
I think it was the last question. Is this in the lab or? Yes, I think lab only
Okay.
because we were talking about the the lab and the class.
Oh,
So you were
okay.
asking if they were separate. I was like, yeah, they are.
Oh, let me know when you're ready.
You're good.
Okay, sorry.
Sorry about that.
You're fine.
Thank you so much.
No problem.
This is my first class.
You have a great one.
You too.
Oh, that's fine.
I will see you Thursday.